Hey there, I'm going to show you how to solve a compound circuit. This problem is taken from the review for the final exam. I believe this is problem number 11. So we got to find out how many different ways can three identical resistors be combined so that they produce a different total resistance each time. Just for the sake of doing this numerically, I'm going to pretend like the identical resistors all have a resistance of 10 ohms. That'll just make it easier to show that they actually have different total resistances. So the obvious one that comes to mind is if you have three resistors together is if they're in series. Well, for this one, the total resistance for three 10 ohm resistors is you just add up all of the resistors, and that gives you a total of 30 ohms of resistance. The next most obvious one that comes to mind is what you would get if you have three resistors in parallel. And so if each one of these is 10 ohms, then when you calculate the R equivalent, it should be something close to 10 divided by 3, which is roughly 3.3 repeating ohms. Because it's 1 over 10 plus 1 over 10 plus 1 over 10. And then you take the reciprocal of that. Alright, so already I've got two completely different circuits using three identical resistors. Are there any more? Well, I can think of a compound circuit that has one series resistor with two resistors that are in parallel together. And when I look at this, I see that the parallel portion of this has a total resistance of 1 over 10 plus 1 over 10. That's 2 over 10. That's 1 over 5. The reciprocal of which is 5. So basically, this whole section right here is equal to 5 ohms. And you recall that an individual resistor like this one on the left is 10 ohms. So for this circuit, the total resistance is 15 ohms. And that is different from any of the other ones that we found so far. Okay. So lastly, is there any other way to combine three resistors? I have one in mind. I'm betting that you might be able to figure it out. If you think you can, pause the video right here and see if you can find it. Okay, so hopefully you had a chance to try and figure out what the last one is. And there are only 4 different ones that I believe are in existence. And here's the 4th one. What if you have parallel again, only this time 2 of the resistors in that parallel are in series with each other? Now what does this give you? Well, the smallest piece of this that you can simplify is a series part. And in fact, it's these 2 resistors combining to give 20 ohms of resistance, which, when you consider that that's in parallel with this 10 ohm resistor, means that the total resistance is, okay, so it's 1 over 20 plus 1 over 10. That's the same thing as 1 over 20 plus 2 over 20, 3 over 20, and that is equal to 1 over Req. So Req is equal to 20 over 3. 20 over 3, which is about 6.67, or 6.6 repeating. Okay. And that is still different from the other 3 circuits that we came up with. So there you have it. These are the 4 unique ways to combine our 3 identical resistors to get a different equivalent resistance each time. But the question that is, I think, at the very bottom of the page for the review sheet, it also asks to find the power for each resistor if we're using a 12-volt battery to charge the whole thing. So to do that, you're going to have to watch the second video.